guy right there.
Yeah, I don't remember where from though. OWASP maybe. OWASP. Yeah, I recognize you from OWASP.
Woo!
Oh, is that what you do?
I give out stuff.
Oh, okay.
That's all I do these
Here,
days.
take these hats too. Then. I have song references.
He's been whining all afternoon. Yeah, so I hooked him up with some sponsor swag. All right. First. All right. Right. First thing. Has anybody figured him out yet? Beyond some of the vague references, has anybody?
This?
Yeah.
Oh,
yeah.
I like the way one edge is rated.
Well, it depends. If you look, say again. 22 of them that fit into a sheet. Hey, the first person to see Heidi with a solution gets something. What did? And all of a sudden, Heidi Kahn was motivated.
What does Bruce have to say about that?
We're going to the club, right? And the club is like 21 and over. Who's under 21? Nice try.
We meant age.
The kids aren't in here? Where were they? That's too bad. All right.
They went to DEF CON.
He said, I'm under 21. I don't believe that either.
Oh.
All right.
Okay, this is on tape.
Yes. If there's anybody have any questions? No? You ready to go? All right. I'm friends with this guy, and he has to go get a tape. He said we're rolling. We're on tape.
So no F-bombs.
What do you mean no F-bombs?
Well, you can. I can't.
Oh, really?
Yeah.
Fuck that.
All right.
All right, this is Matt Fisher. A round of applause.
Beetle, what do you think of Gartner? Thank you, everybody. I would like to thank Beetle, Bruce, Heidi, everyone else for putting on this great show. So if you don't know why this is the last track of the day, it was between me and the janitor, and the janitor got sick. So I'm here to talk about web app security. This is, I'm not going to bring out like any groundbreaking, earth-shattering new research. If you're looking for that, then keep your ping pong balls put away anyhow. I'm Matt Fisher. Here's what we're going to cover. I'm going to do a quick comparison of web app sec versus network security. Why? Because a lot of people still don't get it. They still don't understand how there are fundamental paradigm differences between web app security and network/host OS security. I've had 2 giant Starbucks. I'll start stuttering at one point. If you really can't make out what I'm saying, stop me and I'll type it. We're going to go through some cross-site scripting. Why? It's kind of old news, but it's still out there. I want to talk a little bit about XSS proxy, which was unveiled here last year. SQL injection, some spot techniques for working through trouble areas in SQL injection. Blind SQL injection, and a couple of funny slides on some really evil things you can do with SQL injection that people just really don't think about. If there's time, I would like to demonstrate parameter manipulation to get through ACLs based on a really horrible demo site that I built mimicking a real government site I did, legally, of course. I want to show a fun page I made for when you get the ability to do uploads and talk about web dev for a second. And then I really want to talk about managing web app sec because that's what a lot of folks don't get. It's relatively easy to learn web app sec at the technical levels. It's difficult to figure out how to actually implement application security programs in your own organizations, the challenges, the process. So I definitely want to talk about that. If an area is too slow, tell me to speed it up. If it's too fast, tell me to slow it down. If you have short questions, throw them out there. If it's a question designed to elicit like a 20-minute debate, let's do it afterwards. And if I have little musical references sprinkled throughout here, I forget where they are. If you see a musical reference and you can like name that band or something, I'll give you a hat, or Beetle will throw a CD at you. So with that, I want to move on to web app truisms. The first thing you have to realize is web applications are software. Sounds silly, right? You take that for granted. But you go talk to a lot of web app developers, go talk to your own development teams. They don't realize they're building software. They'll say they build web applications. Yeah, they're not operating systems, they're not drivers. But you look at any commercial website out there, and they're measured in like KLOCs, MLOCs. It's big, complicated programming. And if, the big giant OS manufacturers that we all know and love, with all the resources, like more resources than God, can still continually make 25-year-old mistakes, think about your own web development team, how much training they have, how much time they have to build stuff, right? How many resources they actually have, and then think about how many mistakes they make on a daily basis. Unfortunately, development standards still emphasize functionality, efficiency. There still are not many development standards for security out there. App security has not infiltrated the development world the way it needs to be. It's still done by the security teams, which is wrong. Application security needs to be a metric of software development, not a pen test, not anything security ops does, right? By the time security ops comes in and does anything related to AppSec, it should be purely validation, right? Did those guys do it? Okay, it's good. Unfortunately, a really big the C-level types, the folks who really have the power to make sweeping changes through their organizations, really understand technologies like IDSs and firewalls. They don't really get new stuff like web app security. That creates kind of a fundamental difference because it's kind of like preaching that the sky is falling. At times, it can feel like banging your head against a wall, but you have to keep banging against that wall. You have to kind of sell the dangers of it internally because every CIO out there knows that they need IDSs and they need firewalls. They totally need secure applications as well, but they don't have, analyst reports and magazine covers and throwing that in their faces every day. And then, of course, web app dev is now approached as engineering. You build an operating system, you build a serious piece of client-server software, mainframe software. They approach it as an engineering discipline. They make their documentation, they design it, they build it on paper before they even start coding. Web app development is trial and error development. I'm guilty of it. Every web developer is. You build it, you test the function, does it work? Okay, do the next function. Okay, great, let's try this class. Nobody sits there and diagrams stuff on paper before they build it anymore. It's totally ad hoc development, and you can tell. Now, the ironic thing about web applications is they're totally the most exposed thing on the entire system. I mean, the whole reason you have firewalls and patches is to keep that application alive and serving. At the same time, it's the most difficult area to secure. Just rolling up the stack real quick, network layer attacks. Okay, now don't slam me on this. I'm not a network guy. I know there are plenty of people here who can talk all sorts of IP fragments and IDs and stuff. But for the most part, if you can block access to the network off with a firewall, you can secure it pretty easily. You can monitor for those types of attacks fairly easily. The OS, if you can block access to like NetBIOS, you remove a whole lot of risk right there. Patches and hardening and configuration management take care of a lot of problems. The web server, of course, is always exposed, and there's always the latest IIS overflow, the latest Apache chunked encoding. That sort of thing always occurs. But still, you can get a vendor patch and go back and fix those. The application itself, however, that web app is your own software. You can't put a firewall in front of it, obviously. There's no patches. There's no automated hardening. No one's going to write a guideline that says, here's how to harden your application. Monitoring at the web application level is a real challenge. I'm not going to say it can't be done. I've met some really innovative folks, Todd, Cameron, who've come up with good solutions for trying to monitor for attacks. It's still a bear. Now, more comparison with host security. By host, I just mean network OS security. They get a lot of benefit from the fact that they deal with a homogeneous environment, right? If you find the next latest and greatest Windows XP overflow, it affects every installation of XP exactly the same, right? It's uniform software. It's COTS software. So that means when someone finds an overflow on XP and they announce it once, the FT it once, it applies to everybody the exact same way. So we all learn about the issue at the same time. The vendor can go back and write one patch that fixes every installed seat. You have things like patch management tools that help you apply it. And then you have all sorts of great network scanners and testing tools that help you go back and make sure you actually applied that patch. With web app, you don't have that. Web application vulnerabilities are as custom as the software is. Now, there's lots of COTS web apps and like canned PHP and OSS stuff where you can absolutely make an announcement and it affects every PHP BB exactly the same. But for your own custom web apps, no one can sit there and tell you where your vulnerabilities are based on testing they did on their own stuff. Therefore, when you have these web app vulnerabilities, you will not know. You will not get an announcement. No one can give you a fix for your software, for your JSPs, your PHPs. Scanning tools, well, I'll be careful here, but the scanning tools that most people use that we're used to using on a regular basis aren't designed for that sort of testing. And the management of these vulnerabilities is just overall more difficult because they're so unique, they're so custom, and you can't apply a patch. That's really the hard part. The bottom line is These vulnerabilities came from your software. They're your problem. You have to deal with it. Now, because these web application vulnerabilities exist in your own software, in the ASP, the PHP, the JSP, the Cold Fusion's great stuff, it means that these vulnerabilities affect all web applications, regardless of the operating system they're running on, regardless of the patch level, how solid the OS is. I've personally busted lots of military systems that were, patched up and CNA'd, perfectly good to go according to DITSCAP, DIACAP, but their web developers made a couple silly mistakes, and I owned them. The best example is a C2 tactical system out of MAGCOM, where they DITSCAP'd it. It was solid, according to the entire DoD security process. All green lights, no waivers. In 10 minutes, I got the source code to the entire system because of application-level issues. They're extremely easy to exploit. This is stuff I can do. They're orders of magnitude easier than buffer overflows. Orders of magnitude. And again, difficult to deal with at the perimeter. SSL, often really hides your traffic quite a bit. If you do want to deal with it at the perimeter, it's doable, but you're going to have amazingly granular rule sets that will change as often as the application does in many cases. Now, typical security models, right? NIDS, HIDS, AV, spyware, firewalls, the whole 9 yards. Typical web AppSec practices. Right? I just came from a DoD conference. That's why it says this page intentionally left. It did say DoD web app practices. This is bug track from earlier this week. Okay, this is validation to me personally. The bug track summary that just came out this week, and like the last several of them, are just riddled with web AppSec issues: SQL injection, HTML injection, input validation vulnerabilities. Remote file includes, right? Running your own code through tricking the app into running your include. Cross-site scripting is all over the place. And cross-site scripting is actually the first thing I want to talk about. I stopped talking about cross-site scripting like a year and a half ago, but what I'm seeing now is that a lot of people are just kind of poo-pooing cross-site scripting. Like, it's not that important. It affects one page, you get a cookie, whatever. Cross-site scripting is actually really dangerous, thanks to what Anton revealed last year. How familiar are folks really with cross-site scripting? Hopefully everyone in this room should really know it. Okay, we got a lot of folks here new to web AppSec. Yeah? Good. Good, yeah. Numish is trying to learn this stuff. The way cross-site scripting works, the first step is you have to find a site that replays something that you put into it. In this example, it's a login field. These can be common. Search fields are really big for cross-site scripting. You search for a book name, and it comes back and says, I can't find your book name. A lot of times, 404s, you search for a page, and it comes back and says, I can't find the page you asked for. But you find some portion of the application where you type something in, and it spits it back to you. Then you see if you can put script in there, put HTML tags in there. You see exactly what you can put in there and have it spit back to you without validating. In this case, you can put a full script in there, and it spits it right back. It says the invalid login test. Now, the reason it says test is because I inserted a document.write and said write the word test in the JavaScript. So you're basically, it's kind of like you're handing the server the script you want to execute. It pushes it back to you in the response and executes on your machine. And then, and that's fun for 5 seconds. The whole thing is you do an alert box that pops up a little message that says XSS. It's silly. But when you have like a get-based XSS, when it's an HTTP get, meaning all the information is passed to the server in the URL, in the address line, it's trivial to put some nice malicious JavaScript in there and spam it out to people and try and get other people to click that link. Lance James just did it was an awesome presentation on phishing. He has seen cases of cross-site scripting in phishing. It's common in blogs. I've seen a few in emails, not a huge amount. But the whole idea is you create this attack vector. You try to trick someone into clicking the link. When they click the link, they go to the server. They pass the JavaScript up in the URL. The server plays that JavaScript back to them, and the script executes on their machine. Now, the vectors can all be pretty varied. Here's one we did years ago that just said, hey, we're a bank. We've deposited $200 into your account. Click here to get the money. If you actually right-click and view the source of this HTML, we all do that, right? You view source on HTML email before, if you view the source, there's lots of encoded stuff in there. If you decode it, it's a cross-site scripting attack. Now, the first thing we did in this cross-site scripting attack is we truncated the form. We put in a closing form tag. The portion where we came back was right where the beginning of the tag opened. So we closed off the developer's form, and we write our own. Now, when you do that, you want the form to work properly. Right? The beautiful thing about cross-site scripting is, especially when used like with phishing, is you're on the real application. If I get a phishing email that says, it comes from Bank XYZ, and I click that link, and it takes me to Bank XYZ and uses a cross-site scripting against me, I'm really on the Bank XYZ website. I'm not on, bankxyz.tv or bank12.us. It's the real website, so you get a lot of trust in there, and you want things to work. So we truncate the developer's form. We make a new form that logs in. You would have all the hidden form fields you need for everything to work properly. All we do is we slip in an on submit event, right? Now, here's like the first myth of cross-site scripting. I've come across a lot of developers who strip out script tags, right? Open bracket, script, close bracket. That's one way of inserting script, but JavaScript has events, and you can insert JavaScript into any other tag and use a whole bunch of different events to get it to fire. There's an onload event for when the page loads. There's key down, key up. There's on submit. So what happens is the user goes in, they put in their username and password. When they click the submit button, we create a new image, right? And this is like standard, plain vanilla, generic XSS demo. We create a new image. The source of that image is roguebank.com, followed by the username, right? Whatever happened to be in the value of the login field when they clicked the button, and a colon, and whatever happened to be in the value of the password field when they pushed the button. That's the caffeine talking, sorry. So what happens is when they get the email, they go here, they put their username and password in, they click the button, they log in. They really do log in. We're passing everything in so they log in. They see their account. It's their real account. There's no alarms, no surprises. Thank you. All right. Who was that? Okay. You get a hat. All right, I want to make sure I don't go more hats than I have. All right. For the rest of you all should have known that. Come on, Radiohead. But the second they click the submit button, right, their username and password was sent off in what's basically a web bug, in an image call off to a third-party website. And when you demo this, it's really cool. All you do is you have a second laptop or a VMware image, and then you hit the access logs, and it's full of 404s with usernames and passwords in it. File not found, Matt/Matt. That's my real password. What else can you do with cross-site scripting? Well, I mean, really, the amount of damage you can do with cross-site scripting is limited to the DOM and your own creativity. The DOM lets you do some pretty cool stuff. You can get to document.cookie, right? So you can grab the cookies, which may very well have a session ID in it. And if they're practicing really weak, archaic, simple authentication controls and session management, that session ID will let you write into the application. You can also control the location the browser's at. You can write your own HTML, which is often fun. I've done dynamic defacements, where the defacement only exists in the browser because the defacement was all in script and HTML that was in the URL. You can open and close windows. You can pop up windows and do the X10 thing. You can also draw frames, right? You can draw frames and make requests for new scripts. How many folks were here for Anton's presentation last year? I personally was not. I could not make last year. I was overseas. But Anton basically showed the world that cross-site scripting is actually super duper dangerous. I mean, web app set guys have always kind of known this. Once you get the ability to execute script, the DOM has a lot of creative stuff in there. And if you really exercise it and play with it, you see the potential for it. Well, he went ahead and realized the potential and made something called XSS proxy. It draws an iframe, right? And the source of that iframe is a script on his own machine, right? It's the XSS proxy software running on his machine. And that software basically keeps a persistent connection alive, right, with a timer event. So every couple of seconds, the victim's browser requests a new script, and he takes the HTML from the page, right? You can do that in the DOM, the .inner HTML. He takes the HTML from the page, encodes it, chunks it up, passes it back and forth between these two scripts. So you click the link, right? And normally people think that cross-site scripting is limited to the cookie and any form values on that one page. Well, now by creating this persistent connection and passing the HTML comments, he can see the web page you're browsing, right? Because the little script that's executing in your machine now is passing the contents of your web page back to him. And likewise, the proxy can push more commands back to the browser. And what they essentially did is figured out that now you can see everything they're doing on the site. And then if you get really advanced with it, you can start seeing what they're doing on other sites. It's a very interesting paper. He did it here last year. I think that was the first time he talked about it. He's doing more on it. And there's the URL right there. Cross-site scripting is now as evil as everyone always suspected it is. The XSS proxy really brings cross-site scripting back into the forefront. So don't let anyone tell you that cross-site scripting is silly, that they don't care about the documents. Don't let them tell you that, okay, well, we found XSS, but it's on this page that doesn't count. XSS anywhere is now super serious. Capiche? XSS defenses, input validation, right? Always validate your input. It's funny, 20 years ago, what we call software security, they just called software, just good software, right? They would, you would never find a program 20 years ago when you really had to study to do this, right? You had to go to school and do all this stuff. They would never write a function that just accepted any input. They're like, no, my function expects an integer. I'm going to make sure it's an integer. Nobody does that anymore. Always validate input. I'm going to talk about good input validation, bad input validation later on. You can also validate your output to prevent XSS by HTML encoding. This does not mean you only HTML encode the output and do not validate your input. I've seen some presentations that give that advice. I don't like it. Always validate your input. Okay, SQL injection. A lot of people know a little bit about SQL injection. Some people know a lot about SQL injection. There's basically two types of SQL injection. There's verbose and blind. Now, some people call the first one error-based. I think they're misguided. The whole thing is with verbose SQL injection, you're getting ODBC error messages back that guide you through the technique. With blind SQL injection, the website's keeping mum, right? It makes it much trickier. Now, SQL injection, again, I've heard so many misperceptions about it out there in the field. I've had at least like 50 PMOs and project management offices, the people who run the projects, tell me that, well, our website is public information. I don't care if someone does a SQL injection. They can read the information by browsing the website. If they want to do some fancy injection thing and read it that way, they can too. That's not what SQL injection is about. SQL injection is about getting owned. Before I want to show you that, though, I want to walk through how SQL injection works. How many people here are really intimately familiar with SQL injection? Okay, well then bear with me. Wow. Obviously, the first thing for SQL injection is find a page that uses SQL, uses a query in the back end. Easy enough. Here we have error code equals 2. You increment the number, you get different error messages back. Then you do some sort of test. All right, let me back up. The reason SQL injection is available is the way they do the query. SQL injection really doesn't have very much to do with the database. It's the way the web developer calls the query. It has nothing to do with MS SQL. SQL injection works against MS SQL, Oracle, PostgreSQL, MySQL, right? It's all about how they build the query and pass it on. This is a really bad way to build a query, but it's a very common technique. It's given in a lot of examples, and so people just kind of follow the examples and write this way. You take the portion of the query that's static, that never changes, and you throw that in as a text, as a string. Then you take the portion of the query that does change, the error code, and you slap that on the end. You pull it from the HTTP request and you slap it on the end. No input validation, not good. This is also a very inefficient way to build a query, just performance-wise. It's a poor way to do a query, but again, developers know what they know. They follow examples. You can go out to a zillion different websites. You can pick up security books with code samples in them, and they will show you this stuff. And sometimes you'll even say, in the real world, you would do lots of things to secure this, and you would. But unfortunately, if you're reading an example and that's what you see, that's what you do most of the time. The problem, obviously, is unvalidated input. You throw in, the usual single tick mark. There are actually lots of different things you can throw in to test. A single tick mark is the classic example. A lot of IDSs now look for this. So don't go home and try this on your bank. Do it from the hotel room. Do it from that totally owned wireless in the bar. You throw in a single tick and you get an ODBC error message back, right? Because the single ticks are text delimiters. They're expected in pairs. And all of a sudden, the query only has one. So the database pukes and throws an ODBC error message back, right? This is highly significant. You find them all over the place just normally browsing. In fact, there are funny things you can do to your browser to make them show up even more often. But you find them everywhere. Yes, they're a functional issue. They're a big security issue because it means I put something into that field that doesn't belong. The application didn't validate it. It took it, slapped it onto the end of the query, and ran it against the database. Then took the results from the database and printed them to the screen. Now, in this case, the results are an error message, right? But what this means is that error code parameter is a two-way pipe to your database. I put something in that doesn't belong, it runs, I get results back, right? Now, the challenge then is put something in that actually works instead of just breaking. Against an integer, you can do a really simple union attack. Union is a highly reserved keyword that tells the database you're giving it two different queries and you want it to combine the results back into one record set. Now, the first part of the query is going to be the static portion of the query, the hard-coded query the developer wrote that you can't do anything about. The second query is going to be your own. You put in a good value or a bad value, followed by union select with your own query. Now, against MS SQL Server, the first query done is usually select name from sysobjects. Sysobjects lists every table in the database. You can pull the name up. There's hundreds in there, so you have to filter out by using x type equals u. There's x type equals s, which is system tables. You want the user tables. So you do a simple union select name from sysobjects where x type equals u, and the application takes that input, appends it to the end of the query, not realizing that it's now modifying the query. It's taking what is supposed to be a parameter to the query. Let me back up. It's taking what is supposed to be a parameter to the query, a value, right, in the where clause, and it's actually modifying its own query without realizing it. So what happens? It takes it, runs it against the database, prints the results back to the screen, and you get a list of table names in 2 packets, right? In 2 HTTP packets. Now, obviously, that's ideal circumstances. SQL injection gets complicated real quick, but I've done plenty of sites where you get the plain vanilla stuff, and in like 2 packets, you have a list of tables. And if you're doing it over SSL, that could very well be 2 packets that's tunneled through the IDS. The next task, if you want to do a proper query, is to find a column name. You need select column from table where something equals. There is a table of columns called syscolumns that has a primary key called ID. So you can select the columns for a certain table if you can join it against the ID for a table name from within sysobjects. You can do that with a simple subquery. This one just says select name from syscolumns where ID equals subquery, select ID from sysobjects where name equals bank underscore cards. Sure enough, it brings back a list of columns, right? 3 packets. 4th packet, row level data. So now you have table name, you have column name. Now it's just union select card number from bank underscore cards, right? And you get data. Everyone follow that? 4 packets. Not always. It's not guaranteed to be that easy. These are obviously like demos. But you do enough work out there, you will find plenty of sites where it really is that easy. I have a cousin who works for a really large commercial real estate company, and he asked me to look at his site once. And here's some intuitive hacking for you, right? Hacking with the force. News headlines. SQL injection on news headlines. It's there every time. The scrolling headlines where you hover over it and it says something like show full article, article ID equals 12, right? Those things are always injectable. Why? Because it's headlines. Who cares about them? Right? It's marketing stuff. Nobody's going to like spend money to secure that. They're always injectable. And sure enough, I went there, 2 keystrokes, found the injection. 5 minutes later, I had the whole database. That stuff really does happen in the wild. Here's some more techniques for SQL injection for when it gets a little more complicated. What if the page only returns 1 record out of the row? What if instead of saying like loop through all the record sets and print all the record sets back, we just print the record set once? Well, then what you have to do is start incrementing your queries. Say, union select card number from bank cards where 1 equals 1 will bring you back to the top row. You get a card number back or row level data of any sort, and then all you have to do is do the same query and say, bring me something greater than what you just gave me, right? They support booleans with text strings. So you can say, okay, bring me the next one. You just gave me Matt, give me whatever is greater than Matt. Dealing with strings, that's when you start getting all the single quote stuff everywhere. Injecting against integers is tons easier than injecting against strings because there's no quotes needed. Now this dispels the whole magic quotes thing, right? Magic quotes was not meant as a security tool. You can find an interview with Rasmus Lerdoff where he says, I got sick of help desk calls, right? So I built magic quotes. It's not a security feature. It's just escaping quotes so your queries don't break going in. Magic quotes won't do a dang thing for you against integer fields. But if you do have quotes in there, like injecting into a string, then you have to escape out by putting your own quotes in front of your injection to terminate the programmer's quotes. And then you're going to have the programmer's quotes following on the trail end. So you just put some where clause that won't affect your query, right? Like 1 equals 1, A equals A, Z equals Z. And you leave your trailing quote off, knowing that the programmer's quote is going to be appended onto the end. It completes the query, executes. Now, what if the page doesn't print the response at all? You have like error messages. They haven't suppressed error messages, but they don't print the response to the query. They use it for something. Well, in MS SQL, there's a function called convert. Convert is used to convert data types back and forth. Convert an integer to a string, a long to a short, right? You cannot convert a string to an integer. That doesn't work. And when you try that, convert will fail and say, I could not convert this string into an integer. Duh, right? But the problem is, it tells you the string that it couldn't convert. So you use the convert function, to see what the string is. If you're trapped in the middle of a query, like in the middle of a where clause, you can just throw comments in there, right? Throw the double dashes in there. Throw comments in, and everything that follows that will be left off. Which also shows, though, there's a lot more to validating against SQL injection than just like single quote or, right? The single tick is what everyone really knows. There's lots of different things in there you have to validate against. For instance, first of all, doing selects is like just a fraction of what's available to you in the SQL language. The SQL language is really robust. Good DBAs will build, manage, and kill their databases entirely through SQL scripts, right? And if you go through and hit the books online and start studying stuff, go to sysobjects and start querying for like SP. Look for things like select name from sysobjects where name is like reg, right? And look at all the stored procedures that come back with reg in the name, user in the name, login in the name. Tons of amazing stuff. So here's some fun stuff you can do that don't use a single quote. No single quote. Semicolon. Why? Because they're not queries, they're commands, right? You can shut down a production database with no single quotes. Semicolon shutdown. You can drop the database. You know what happens when you drop a database? Yeah, the server forgets about it. It also deletes it from the file system, right? How many people have that much faith in the tape backups, right? You must work for UPS. You have everyone else's tape backups. There's stored procedures that will show you who the system's logged in as. Of course it's logged in as SA. They're not going to partition their database security. You can add your own users, but in reality you really don't need to because you're already executing on your, what? Say it louder. No, I told you. Loser. All right. Ping pong ball him. Shmooball him. You can port scan with SQL injection. MS SQL, and I'm pretty sure Oracle, will support these sort of chained queries where your query to database A forces it to query database B. Normally, you go in and set those relationships up ahead of time, but there are some commands that will take that relationship set up in an ad hoc fashion, like doing a DSNless connection string. Open row set is one of them. So you can do an injection that uses open row set, which tells database A to open records from database B. When you do that, you have to tell it how to connect to database B. You have to give it a server name, a port, a username, a password, right? So here, all you do is you specify the database that happens to live at Yahoo on port 80. There's no database server on yahoo.com on port 80, so the SQL server complains. But when you do the exact same thing for port 21, it complains in a different manner. And that right there is all you need to port scan, right? Open, closed. You can also do this to like brute force SA on other databases. Let's say you're port scanning, you do find a second backend database, and it's listening to you, but it's authenticating, and you have no idea what the credentials are. Well, since you have to specify the username and password in here, you can use this to brute force stuff. You all missed that one. Ha, 9-inch nails. Now, the cool thing about when you're doing that, you're already behind 2 layers of security, right? You're already behind the first firewall in front of the web server. You're behind the second tier firewall in front of the database at this point and going backwards, right? You know that's going to be wide open. I have a customer who got hit with SQL injection and they took over 80 client machines before they realized they were owned. SQL injection is pretty bad. It's not about reading data. It's about being owned. They are running commands on your database. The commands they choose to run can be simple select statements, or they can be inserting users. There's a German guy right now working on rootkits and Trojans for databases under the theory that a database server is so complicated, it's basically an operating system of its own, which I totally buy. Who's vulnerable? Everybody. Now, here's the thing. No, seriously, there's so much SQL injection out there, it's ridiculous. Here's the thing, though. Those ODBC error messages are just the symptoms of the problem. They are not the problem itself. The problem is the way the query was wrote. You can't use string queries like that. You have to use parameterized queries. You have to use bind variables. But a lot of developers associate those ODBC error messages with pain, which is good, right? But so they go back and they implement some error handling. They suppress the ODBC error messages without actually fixing the underlying problem. That is when you get something called blind SQL injection. And you know what? In my opinion, blind SQL injection is worse for you than regular SQL injection. Why? Because you can go through an application and put single ticks in there, and as you're using it, see these ODBC error messages and go, oh gosh, we have a problem. With blind SQL injection, there's no error messages, so it's that much more difficult for you to detect. Remember, you don't have the time while you're doing these assessments and certifications that the hacker does. A hacker can hang out for as long as they want testing your site. You have a day, a week, a month to get it out the door. So in my opinion, blind SQL injection is more of a threat to the people running the site than the hacker. It is a more difficult technique. It takes longer. But the fact that it's that much easier to slip through your testing. So what it is, I took that same demo site I just did, and I changed it so it doesn't print any records back to the screen. It uses an on-error resume next, so there are no error messages, and it doesn't print any records back to the screen. So I can't say like union select name and have it print the name of the table back. The general process you use for this is you find some sort of Boolean behavior in the application where you can kind of get it to indicate a yes/no. It's just like the SQL, the port scanning thing. It doesn't really matter what the error message is or what the conditions are, as long as there's one for open, one for closed. If you can get one for yes, one for no, you have all you need. Then you start asking lots of repetitive yes/no questions and writing it all down. So here, the exact same site, I do an on-error resume next, and I remove the response.write. All I say now, all I do on this site now is if a record set comes back at all, write the words in stock, okay? So nothing from the database is written to the screen. I throw a single tick in there, nothing. So I won't be able to just use a union attack. Here's how you go about it. For blind, you can throw in just a simple modifier, and 1 equals 0. That's a false condition. Now notice when I put that in there, the application comes back with that silent stuff. It doesn't say in stock when I just do like a 2 or a 1. It comes back silent. Now the question is, okay, it doesn't like something I did. I generated an error, but it's just telling me there's an error. It's not going to give me the results of the error. Is it because they're validating and they don't like the fact that I put and 1 and 0 equals 0 in there? Or is it because they're not validating and the 1 equals 0 went back to the database and the database said non-true condition, this doesn't work? That's the question. Well, so then you throw a true condition in there, you throw 1 equals 1, and you get the page returned properly? So, well, now you know, well, okay, it's not because the application didn't like the 1 equals 1, or it would have not liked it here. So it's obviously going through the application and hitting the database, right? You have this blind condition now where you've deduced that you're passing stuff through. You've also figured out what the application does when the query is false, what it does when the query is true. You have your yes/no question. Now it's a matter of using that yes/no question. You can use the substring command to isolate specific portions of what's returned to your query. You don't want to ask yes/no questions against full table names, right? You don't want to do like the $10 million list brute force attack looking for bank underscore cards, bank under logins. You want to isolate one letter at a time and just brute one letter at a time. The substring command lets you give it a string, tells you what position to start at and how many characters to read in. So if I give it fish and I tell it to start at 1 and read 1 character, it returns F. It returns F1, right? You can use that to start guessing stuff. You can use booleans with strings, so you can say, is my first record returned like greater than M? The problem is you don't want to return everything at once. You cannot do this against the entire record set at once. If you say select name from sysobjects, you'll get like 20 tables back, and that doesn't work. You have to restrict it down to 1 table name returned. You can do that using top. Select top 1, right? And then you don't want to guess the full name at a time. You want to guess one letter at a time. Fortunately, substring will take a query as its input. So you do a substring with a select top 1 name, right? And then you tell it just to read in the first characters. I know it's tough to read in the back, sorry. So now you're asking for the very first record in sysobjects, the name of the very first record, just the first character. And then you throw that in with the boolean and say, is it greater than M? Why M? Because you want to bracket. You don't want to actually do 26 packets going A, B, C, D, E. Say again? Damn, where? 20 questions? Oh, no shit. Okay, cool, man. All right. So then, like, will you FTP to? Okay, cool. I got some edification. So now I'm pulling my first word, pulling the first letter, and asking if it's greater than M, and you bracket from there. You don't go A, B, C, D, you go M. Okay, it's less than M. Is it greater than G? No. It's between A and G. Okay, it must be B, right? And you've gotten the first letter of the first table name. It's slow. It's tedious, okay? That Canadian trying to look like a Texan created a tool called Absinthe that does it pretty automatically. He said he actually has a version that kind of quasi-works that's going to be coming out soon as he sobers up. SQL injection is completely automable. People have scripts. Like we have a GUI for it. It's the methodology has been figured out, right? It's totally automatable. And then all you do is you keep repeating things and shifting the letter. Shifting the letter. Now, brute the second letter, brute the third letter, and go right down the row. It works. It's a pain in the butt. It works. Remember, hackers have time. They have hardware, right? They live in their mom's basement. I didn't say that. Okay, I want to go on a diatribe about input validation real quick. I got to really super speed things up. Really good advice on input validation right here, right? No, seriously. As you know, there are known knowns, right? You know what you know, and there's some things that you don't know that you know, the known unknowns, and then there are things that you don't know, right? No, I mean, he makes perfect sense. Okay, granted, he had the whole speechologist thing going, but it makes perfect sense, and you need to apply that to input validation. Do not blacklist input validation. Blacklisting means you see a presentation, you go, single ticks are bad, semicolons are bad, and you go back and you write code that removes all the single ticks and semicolons. Wrong, because you don't know, thanks man, you don't know what all the bad characters are. I don't know what all the bad characters are, and people have figured out how to get by that stuff. What you do instead is you whitelist. You go, okay, it's a zip code. I'll only let a zip code through. It's a phone number. I'll only let a phone number through. You use parameterized queries. You HTML encode. Okay, I want to talk about parameter manipulation real quick. I'm going to have to do static slides instead of the demo because I have just way too much content. Parameter manipulation is when you change values from one good format to the same good format but different value. Injections are pretty clearly don't belong there, right? But what if you have like customer ID equals 2 and you change it to customer ID equals 3? That happens. Victoria's Secret got nailed with it. That's an inside joke. You went to the order status page, which is like everybody's favorite whipping post, and they did state fine up until the point where you actually got your order confirmation. But if you started incrementing integers, you get other people's order confirmation. No taboo information, no socias, no credit card information. The New York State Attorney General still came down on them because they violated their own security assurances. They made assurances on their website that said, we do this and that, and they didn't. The worst damage as an individual really is like, you're going through the list and you find your girlfriend in there or something like, she'd be, oh, that, I've never seen it. But if you make assurances on your website, you have to live up to those assurances. Gateway computers, you'd expect a little bit more than an e-tailer, right? They had the exact same thing problem. They gave up some credit card information, including the CCV. You are not allowed to store the CCV. Guess who else recently leaked CCVs? Guardian Software, who makes Encase. I just came from a big DoD cybercrime show where every single attendee there was a special agent, right? I met special agents who had their credit card info lost, right? They were storing the CCV. Visa could, by all rights, pull their rights to process credit cards, to be a credit card merchant. And Guardian makes Encase, big forensic software, right? Every FBI, OSI, all those guys use it. So when they lose credit cards, it's really bad, right? And of course, in the article it says we're working with the Secret Service. Of course you are. They're breathing down your neck. They want to know where their card numbers are. Anyhow, for parameter manipulation, a lot of it, of course, you can do by hand. Fuzzing is very common. A fuzzer is a tool that lets you take a packet and say, like, do things like increment these numbers, change these characters. So I saw this one site where they had a link to a page ID equals 8. And that page ID equals 8 was a redirector that would properly authenticate you, but I thought it was odd that they started at 8. So I went and fuzzed it from 0 to 100. And what I found was that there were lots of pages behind that redirector. And you can show, in this example, I could go just by the status codes. It doesn't have anything to Shmoo because of Shmoo. I needed different web pages to make this demo in DallasCon. I just grabbed theirs. But you can go by the status codes, and you can say, like, page ID equals 1. There's something there because it issued a 302. The 302 is back to login. So you can go, okay, there is a page ID equals 1, but it's properly authenticating. But then there's, page ID equals 2 gives a 200. So there's a page there, and it's not authenticating. Real quick, easy way to check access controls. WebDAV. WebDAV is an extension of HTTP that gives you extra verbs, basically. It gives you silly verbs, like puts. You have to use WebDAV if you use things like front page, don't. Visual Studio, do. And every once in a while, someone slips up and really misconfigures them. If you check in IIS, if you check the box that says write, you will allow people to push, anonymously write Non-mapped files. Non-mapped meaning if you go into the application configuration, you look at where they say .pl gets processed by perl.exe, .asp gets processed by the ASP, ISAPI filter. Those are mapped extensions. So if you check write, you let people put up text and HTML. If you check write and allow source access, you let them put up mapped things like ASPs. So I had a customer who found that and wanted to really scare her developers into action. Yeah, I know, I'm way behind. And so I started working on exploit, and I came up with this little web page. I'm proud of it. This is about as hackerish as I get. But it's a single ASP with no external dependencies. It uses Windows scripting host, which is pretty much required on the box. It's never removed because ASP files rely on the WSH for file I.O. It uses a relatively obscure, undocumented, buggy feature of the Windows script host, not WSH.run. If you're a WSH coder and you want to look at it, you want the code, I'll give it to you. I'll talk to you about it. It actually uses the .exec. And all you do is you type in your DOS commands, and it brings you back the results of the DOS commands back. So you can do make right? It's a DOS prompt essentially, a very nicely formatted one. And what I like about this is, yeah, you can upload netcat, you can upload back orifice. There's tons of different things you can upload, but people have signatures for that. Like if someone sees a new exe sitting in their web root, that's highly suspicious, and there's a really good chance that AV scanners and stuff are going to find it. This is an ASP file. I'm not aware of any tool, any product that will go through and look at your ASP source code and go, wait a minute, there's a call here that doesn't belong. I'm not aware of anything that does that. And it's another, you can call it default.asp. You can call it, backup.asp, don't delete me, whatever you want. It's very, from kind of a human being perspective, it's very stealthy because of that. And it works nicely. So back to the static stuff. Okay, directory browsing is all over the place. Not so much in the commercial world, but all over the government world. Directory browsing is a matter of what can you browse, right? But check this out, datacon.inc. That stuff is all over the place. You won't believe how many developers use DSNless connection strings, which means they have to hard code the database credentials into the page. If they use an extension on the page that is not mapped, the web server doesn't know to execute that server-side source code, right? It has no idea that this file contains Perl or Java or ASP because it's not a .jsp, .php, .asp. So it falls back to text and gives you the source code, and you get database connection strings, right? Now, am I speaking the truth? Yes, you can Google for this crap, right? It's all over the place. I recently did a really giant company put me on a site where they used RSA secure IDs, and the only page I could get to without authenticating was default.asp. Fortunately, they also had a default.back with a DSNless connection string in it. 30 seconds later, I'm registering their database in SQL Enterprise Manager. And you can Google for DSNless connection strings, right? And check this out. This dude's got the most complex username I have ever seen, right? That shit's tight, aside from being broadcasted on the internet. You can do cool stuff with Google. Go see Johnny's presentation tomorrow. We Google for different sorts of things, but he'll show you how ridiculous Google hacking can get. Okay, managing web apps. This is going to be quick. The bottom line fundamental problem with web application security, in my opinion, has nothing to do with tools or technology. It's an educational issue, right? We are turning out legions of developers every semester who are taught functionality, they're taught efficiency, performance. They are not taught security. Now in C, they're starting to teach things to prevent buffer overflows. But even folks who are fairly progressive in teaching that now admit that in their web courses they're not teaching any security. That is the fundamental problem, and that's the fundamental problem you have to overcome. You have to teach your developers security. There are a lot of other contributing factors as well, though. Most security folks tend to come from a networking background, in my perspective, and aren't really application development guys. And that creates that big gap you have to divide. Development times, rapid development times are killing software. No one is given the resources and time they need to build software correctly. All they care is, can you build it in 2 days? Look, he built it in 2 days and it works. And then 6 weeks later, they're in the headlines of the Washington Post because they got completely owned, but they turned that thing out in 2 days and it worked, right? Big problem, especially in the Beltway. Big problem. There's a lot of copy-paste code. By that, I don't mean that literally people are copying and pasting code, although that does happen. I mean that when you go look at websites, you look at books, you look at papers, there's a lot of bad code examples out there that people follow. So awareness, education, tools, training, design for it. Do not just test in security. I have 2 slides. Then I'll shut the... Okay, govies especially follow a very rigid testing pattern. The commercial world does this too, where you build the system, right? And the security guys have no idea what's going on in development, right? They're in La La Land. You've got more serious issues. But then they come to you and say, hey, we have this program that's about to go live. You know, we want you to test it. So you test it, you run your scanners, you bring your pen testers in, you hack it, you tap dance on it, then it goes live, right? For pretty much everything other than AppSec, that may work, right? Because when it comes to patches, configuration, poor, password complexity requirements, those are all things security people can fix themselves. But if a security person finds SQL injection, they find design flaws, they find bad session management, they cannot fix that themselves. It has to go back to the development team to do that. Well, if the security testing is the last step of the process, what do you think is going to happen when you say, can I take this back to start? Waiver. Yes. Who's the govy? Waiver. Waiver. Or politics. No, you cannot take it back to start, right? We go live in 2 weeks. I had a major say, this goes live in like X weeks, and there's no way I'm going to be the one to tell the kernel it's going to be late, right? Same thing happens in the commercial world, except it's Jim and Bob. You can't do application testing strictly at the tail end of the process. It has to be something you do through the life cycle. Your developers have to test while they're building. Test in QA. That's like big return for the money because QA shops are already test machines, right? They already know how to find defects. They know how to track them, log them, get them fixed, and retest them. And these are nothing but software defects, right? Different implications, but they're just software defects. So whatever you do, if you're not doing any application security testing, then yeah, by all means, start. At least start. But it's really something you have to push through the development lifecycle. So with that, I will now STFU. Here's some references. This is the XSS proxy. We have lots of web papers on our website. I run the Maryland, actually the Washington, D.C. / Maryland OWASP chapter, along with the goofball and the blue trucker hat there. If you're local and you want to learn more about this stuff and hang out and come to monthly meetings, learn about Web AppSec, you're welcome. Our next one is going to be on AJAX and security implications in AJAX. I'm Matt Fisher. I'd like to thank Shmoo. I'd like to thank my company, Spy. And thank you all. Good day. And to the folks I owe hats, come on up. I got one more. Sorry, toss it? Okay, hat toss. Ah. I think I just cut myself. Yeah, right. Like I don't have 50 in there. Hey, man. Only one?
Schmitty, unplug that spotlight, will you?